Right, this is lecture 9 of Calculus 2 and it's on applications of chain rule to the coordinate transformations. Now this will make sense when I show you the first slide. If it will work, why isn't it working? There we go. Definitions, as usual. Right, now this is what we're doing here is normally we're given f of xy, and what we're given now is a different method. So we have polar coordinates. So we have, in this case I've put big F, r theta, instead of little f xy. So normally for grad f we have this function, which is the partial derivative with respect to x with respect to y. But now instead we have this, which is df over dr, so differentiate with respect to r, times er, that will make sense in a minute, plus 1 over r times df over d theta times e theta. Now er and e theta in these places are cosine I plus sine j, and e theta is just the derivative of that, so minus sine theta I plus cosine theta j. You can I remember it as computer science because I dropped it. I can't think of many methods to remember it, but never mind. So on with an example. So this is asking us for grad f of f of xy in terms of polar coordinates. So first of all we put our x and y values in polars over here, so it gives us r squared cosine theta sine theta, and a trigonometric rule, I've put no word for it, is that cosine theta sine theta equals a half sine 2 theta. Now, what we want to do now is we want to find the grad f. So, we differentiate with respect to r, which will give us r sine 2 theta, and we also differentiate with respect to theta, which will give us r squared cosine 2 theta, because the 2 cancels with the half. Right, now we have to put it into this. Yeah, so we have r sine 2 theta er plus 1 over r squared cosine 2 theta times e theta. We put our values in and we separate that shouldn't be a capital I, but it's just done automatically as Word does. And we put all the i's and all the j's together. So if we put it into here, we get the cosine theta I and the sine theta j. And over here, the same again. I've just used that 1 over r and the r squared to cancel an r. So we have the minus sine theta I and cosine theta j. And it's another trigonomic identity you can apply to this, which I wasn't sure of what that was to be honest, but it did it in Maple. And that leads you to the fact, the answer, you can take the r out, and you get r sine theta I plus r cosine theta j as your final answer. And this is the grad f. Or you can put it triangle f, r sine theta, comma, r cosine theta. Right, what's this? This is just a little thing you started in the end. I think we're going to continue in the next lecture. It's a few more definitions, which we'll continue in the next lecture. Local minimums. You should probably know this already from A level, but what we've said here is f of xy has a local minimum at x naught, y naught. These are just values. If f of x naught, y naught is less than or equal to all f of xy, so if x and y can be anything, and it will always be less than it, so it's a minimum there. and similarly the other way around, it will be a maximum if it's always bigger. And these are known as extrema, and we'll do saddle points in the next lecture.